So welcome to our next session. So in this session we are going to discuss about the measurement of an inductance by using the Maxwell's inductance capacitance bridge. Here we are going to study about the Maxwell inductance capacitance bridge. So here let us see the diagram of this bridge. So we are having an 4 terminals. We are assuming the 4 terminals, and this is the point A, point B, point C and point D. Now the unknown choke coil values are connected between the terminals A and B, and this is a standard resistance R3, and this is also a standard resistance R2, and here the variable capacitance is connected in parallel with the variable resistance. So this is R4, and the voltage is connected between the terminals A and C. The voltage across the terminals AB is given as an E1, and the voltage across the terminals AD is E2, and DC is E3, it is E4, and BC is E3, and a deflector is connected between the terminal B and D. Now here L1 is the unknown inductance with resistance R1. C4 is an variable standard capacitor. This C4 is this is the C4. C4 is the variable standard capacitor. C4 is the variable standard capacitor, and R2, R3 and R4 are the known inductive, non-inductive, these two R2, R3 and R4 are the inductance, not the inductance, it is the resistance values. Now the impedance of RAB, impedance of RAB is given as, so let us say Z1, which is equal to R1 plus J omega L1. Similarly, the impedance of RAD, which is equal to Z2 R2, and the impedance for RBC is Z3, which is equal to R3, and the impedance of R at CD, which is equal to Z4. Here it is the parallel combination of resistance and capacitances. So it is given by 1 by, here we are writing as an admittance, in which R4 is parallel to C4. So now here the Y4 value is given as 1 by R4 plus J omega C4. For an balanced bridge, Z1, Z4 is equal to Z2, Z3. So now Z1 is equal to, here it is Z1, Z4 is equal to 1 by Y4, which is equal to Z2, Z3. Again it is simplified as Z1 is equal to Z2, Z3 Y4. Now Z1 is equal to R1 plus J omega L1, which is equal to R2 R3 into 1 by R4 plus J omega C4. Now it is again recalculated as R2 R3 by R4 plus J omega into C4 into R2 R3. So R1 plus J omega L1. Now equating the real and imaginary parts, imaginary parts, R1 is directly equal to the R2 R3 divided by R4. Similarly, L1 is directly equal to the C4 R2 R3. Thus, the unknown inductances L1 and its resistance R1 may be calculated. In this way, we can calculate the unknown self-inductance values. Thank you.